Hello and welcome back to Psychology 301 Learning. This is the second in a series of lectures over Unit 3. This is the second lecture for Chapter 5, and we're talking about instrumental conditioning. And so I want to talk a little bit more about learning about consequences, and in particular I'd like to discuss some of the early theorists, a little bit of the history and background to operant conditioning or instrumental learning. There are several famous folks here. There's E.L. Thorndike and John Watson and Fred Skinner, Guthrie, Tolman, and Kenneth Spence. And so they're just some of the famous names that we'll be talking about as we go through this unit. I'd like to, let me go back here and talk about E.L. Thorndike. I'm sure you may remember E.L. Thorndike's famous experiments with cats back at the turn of the last century, where he would put cats in a puzzle box that would have levers and springs and strings that could be pulled, and the cats would experiment. He would usually put food or a fish or some cat food outside of the cage, and the cats would fiddle around and first reach through and trying to get the cat food, and then they would continue working until they stepped on the right pedal or moved the right lever, and they would escape. So here's a picture of Thorndike's puzzle boxes. In some cases, so here I'll show you, in this case there's a loop that hangs down that unhinges the door, and the door will flop open. And in this case there's a lever that the cat can step on that would allow the cat to open the box. And what he found was that, this is some of his original data, the latency, the time that it took across trials for the cats to escape became shorter. It took a long time on the first one where they did a lot of trial and error learning, and then it gradually began to drop off until it came down to almost no time at all they could escape. And so I guess the big question is, the cats are learning to escape. What's the reinforcer? And the answer is food. But in some cases, the cats never even ate the food. So instead of the positive reinforcement coming from being fed, the cats were receiving negative reinforcement by being able to escape the confines of the box. So when we go back and look at the early part of the 20th century, we find out that the early learning theorists really believed that any behavior that was followed by a positive consequence would be strengthened. And it really didn't matter what the positive consequence was, as long as it was an appetitive stimulus or the removal of an aversive stimulus, and that pretty much all positive reinforcers and negative reinforcers were created equal. They also believed that any behavior that was followed by aversive consequences would decrease in frequency. And basically these rules were viewed as true, and that there was something called the equipotentiality hypothesis, that any reinforcer could strengthen any behavior and any punisher could decrease any behavior. But slowly over time, in the process of experimentation, they discovered that there were some cases in which the animals didn't behave the way they expected. When we go back to Thorndike, his puzzle boxes were very famous, and the cats did escape, and they either earned positive reinforcement for escaping or negative reinforcement for escaping. But he then tried to reinforce a cat for scratching itself. So if you can imagine a cat scratching itself, and he tried to reinforce that behavior with food. So whenever the cat would scratch, he would provide food, and he predicted that the food should increase the rate of scratching or the frequency of scratching. But in fact, it didn't work. Scratching did not increase in this case. He had records of it, but he never really did anything with the data because it appeared that the experiment didn't work. Fast forward, 40 years, and B.F. Skinner tried to train a pigeon to peck a key to avoid being shocked. So he was using negative reinforcement avoidance. So there's a risk of shock, and the pigeon's supposed to peck at the key, and that would stop the shock from happening. And what he found was it didn't work very well. The pigeons did not learn very quickly or very easily to peck at the key. However, when he changed the required behavior from key pecking to wing raising, so he would train them to flap their wings or raise their wings, the birds learned the behavior very quickly. So for some reason, avoid a negative reinforcement of avoiding shock easily could be used to train wing flapping, but it couldn't be used easily to strengthen key pecking. And that was a little bit of a dilemma for this equipotentiality hypothesis. And here's Fred Skinner. He was at Harvard for many, many years. So over time, there were even more problems all the way up through the 1960s. Back in the 1960s, a woman named Marion Breland was one of Skinner's students, and she and her husband, Keller, moved to California to work in the Hollywood industry. They were animal trainers, and they published a paper called The Misbehavior of Organisms, which was kind of a joke because Skinner's dissertation was called The Behavior of Organisms, and so they kind of did a play on words, The Misbehavior of Organisms, in which they described several examples of operant conditioning failing. In one case, there was a raccoon, and the raccoon was trained to take coins. They were big, large coins the size of a, kind of a, not quite a dinner plate, but more like a lunch-size plate. And they were supposed to drop coins in a box in exchange for a treat, and the box had the logo of the bank on it, and it was going to be filmed, and then there would be voiceover put on it. And the idea was that this raccoon was making a deposit, depositing his money. Even a raccoon could deposit his money into the bank. And but as trainers, as they started training this behavior, they gave him one coin, and they trained him with food reinforcement to drop the coin into the box, and that worked fine. But then they gave him 2 coins, and when he had these 2 coins, actually these were a little smaller, the size of like a teacup, I guess, a teacup, the plate that goes under a teacup, a saucer, that's what it is. Sorry about that. So he would take these saucers and he would put them into the box, and then he would take them out. And he would hold them and he would rub them together, and then he would put them back in, and he would take them out and lick them and rub them together and put them back in. And it was like, what is going on? But he wouldn't let go of them. He wouldn't make the deposit. And so it was a problem. Later, they also included in the paper a chicken who was trained to peck keys on a toy piano, and later a jukebox. They tried several different versions. They trained this chicken to peck, but once the music started playing, the chicken would stop pecking and would start dancing. And they were very frustrated that the chicken was dancing. The director, I guess, didn't want the chicken dancing. So they basically had to give up on this experiment, because every time they started training the behavior, they used food to get him to peck at the keys. But as soon as he started actually reliably pecking at the keys, he would do it, but then he would start dancing, and they couldn't get him to stop dancing. And finally, they talk about a piggy, they call him the piggy banker, was trained to do the same commercial, only now the coins were really big coins, and he was supposed to drop them into a bank. And in fact, he was having trouble. He started pushing the coins around on the floor, pushing them under the TV equipment, under the carpeting, and it kind of looked like rooting behavior. And so Marion and Keller had trouble, and they had so many times they had trouble with animals not actually following through on the behaviors that they were training, using food as a reinforcer, that they wrote this paper and had it published. So here they're trying to get a bunny rabbit to play the piano. They probably should have gone into cartooning. It would have been easier. So what exactly is going wrong here? And what we found in the 1960s and 70s is that in each case, each of these situations, the requirement was tied, the response requirement was tied to very strong fixed action patterns. These were food-related, fixed action patterns, And when we look at the situations, often what we're seeing are, instead of the required response, we're seeing behaviors that are associated with food. So, for example, the subjects are starting to respond in ways that are really more consistent with their natural history. For example, the cats. Why don't cats scratch more if you feed them immediately afterward? And the answer would be that cats don't use scratching to get food. Cats use scratching to get rid of itches, and they do other behaviors related to food. And so the behavior, scratching, and food don't really go together very nicely. The same with Skinner's pigeons. They, when you ask them to learn to peck, pecking is a food-related behavior, whereas flying away is more associated with escaping dangerous situations or predators. So they were able to train shock avoidance with wing flapping, but pecking is much easier to train when you use food as a reinforcer. And the Breland's animals are the perfect example. Raccoons wash their food, and they often they'll carry food in both hands, and then they'll put it into a stream, and they'll dip it and take it out and rub it together and put it back in the water and lick the water off. But they put the food in and out of the water repeatedly. That's just part of their natural history. It's part of their natural behavior patterns. The same is true with the chicken. Chickens scratch in the ground when they're foraging. And so they use their feet scratching the dirt on the ground. And to the director, it looked like the chicken was dancing, but the bird was actually engaging in behaviors that were simply part of its natural foraging repertoire. The same is true with the pig. Pigs tend to push their food around with their noses. It's called rooting behavior, and they use their noses to hunt for food. They use their noses to find food, and rooting behavior is something that they do typically. In fact, if you give them a big dish of food, they'll root around in the food until they find their favorite bits. So what's really critical, this is called instinctive drift, where you're getting a trained behavior that rapidly drifts into a natural behavioral response, and in many cases drifts into what would be fixed or modal action patterns. So a really good trainer knows the natural history of their subject and knows the relationship between the response they're asking and the reinforcer that they're using. And so in the 1970s, we learned about this idea called the behavior systems approach that says that behaviors and reinforcers belong together in certain ways, and that there are different systems. There's a foraging system, there's a territoriality system, there's a mating system, and that behaviors and reinforcers that are very specific to those systems work really well together. But when you take a behavior from one system and a reinforcer from another, you're going to have problems. So how do you become a successful trainer? Well, really good operant conditioners know their subjects really well. They understand their natural history, and they try to use the natural history of the species they're working with to sort of stack the deck in their favor. They use that by selecting behaviors and responses that appear to go together. This is very much like the belongingness concept of the 1960s in classical conditioning. And failing to respect a subject's natural history will result in slower learning. You might fail altogether, and you may even get aggression. The animal may become very frustrated. So you really, to be a good, successful trainer, you have to respect the animal's hard wiring, or it's going to undermine your attempts at any kind of training. Now, the behavior system approach basically says that reinforcers activate certain systems. So if you have an animal that's hungry and you're going to use food, that when you start presenting food, you're going to activate that system. So if it's food, you're going to activate the feeding system. If you present them with a mate, then you may activate the breeding or territorial system. If you present them with another, for example, if you take a male three-spined stickleback fish and present him with another male, there are going to be behaviors he's going to engage in. He's going to become aggressive, he's going to bite, and so trying to get him to engage in other kinds of behaviors is going to be difficult because he's going to have this territoriality and aggression system that's kicked in. Predation is another one. So there are different systems, and different behaviors in different systems go together. So behaviors that are in a particular system increase in probability when the animal is deprived of the reinforcer or when the reinforcer is present. So if an animal has not been fed and you bring him into a food earning environment, you're going to get food related behaviors. If you have a fish that's in the breeding season and you put him in, he's in his cage, and you start introducing another male, you're going to activate those behaviors. So it's very clear that when you present the reinforcer, you're going to get certain behaviors out of the animal that will be easy to manipulate, but it'll be hard to manipulate behaviors that are outside the behavior. Behaviors that are not in that system are not going to respond very well to those specific reinforcers. So there's two basic rules. One, if the activated system is compatible with the required response, you're going to facilitate learning. Pigeons are going to peck keys to earn food because pecking goes with the food system. Flying is part of the predatory avoidance system, so they're going to learn wing flapping in order to escape something aversive like shock. Rule 2 is just the mirror image of that. If the activated system is incompatible with the response that you're requiring, you're going to inhibit learning, and you're going to get misbehaviors. So in this case, pigeons are going to fail to peck to avoid shock. Chickens are going to dance, and pigs are going to root their food, and you're not going to get the response that you want. And this is particularly true if the activated system that you're using that's related to the reinforcer includes fixed or modal action patterns or reflexes or taxis or kinesis. If you kick into those biologically determined stimulus response behaviors, you're going to get into a lot of trouble and be very unsuccessful. So this idea that came from the Breland's early paper and led to the development of this behavior systems approach of understanding reinforcement led to quite a few experiments, a lot of experiments. And I have 3 of them that I want to talk about. The first one is by a woman. Her name is Sarah Shuttleworth. She was at the University of Toronto, professor there for years and years and years. And she studied food deprivation in hamsters. Spencer, in 1973, studied stickleback fish and looked at rod biting and hoop swimming in males to see if he could train biting a rod versus swimming through a hoop. And my advisor, Ed Fantino, and some of his students in 1972 looked at Siamese fighting fish and how their behavior changes as a function, how their choice behavior changes as a function of food deprivation. So given the choice between feeding or aggressive displays in front of a mirror, change as a function of food deprivation. So let's talk about Sarah Shuttleworth. There she is. And I mean, how can you not love this? This awesome woman working in Toronto, and she studies hamsters. She's like the most awesome person. So she studied hamster behaviors, and she found two separate behavior systems. The first one is the grooming and self-maintenance behavior system. So she studied grooming and self-maintenance. So these are behaviors where, hamsters are so cute. So you get this, washing their face and using their little paws to wash the top of their head. And so they engage in these kind of self-maintenance behaviors. And then there's the foraging behavior, which deals with hunting for food. So they burrow and dig and crawl around on the ground, and they move. It's a lot of locomotion and a lot of hunting kind of behaviors. And so she described these two sets of behaviors and established a baseline rate for both sets of behaviors. Let me show you what they look like here. So she watched them, and she created what's called an ethogram, which is descriptions of behaviors and the systems that they fit into. So let me use my little cursor here. So here are some of the behaviors that she looked at. So there's, I'm going to start over here. So they're scratching with their hind legs and washing their faces and grooming their bellies and their sides. And all of these fit into the grooming and self-maintenance behaviors. They also engage in behaviors where they dig and burrow and rear up and look around, and they and those are kind of foraging related behaviors. And then there's also other behaviors like scent marking, which is really more related to like territoriality. So so she established a baseline. She got the baseline of how often these behaviors occur in general. And then she withheld food for 24 hours. And what she discovered, then what she did was after 24 hours, she divided her hamsters into two groups. And one group was given food reinforcement for grooming more. So all they had to do was groom and she would deliver food. So they're deprived and they're hungry. And so, and she's presenting food. And the other group, group 2, is also given food reinforcement, but they are given food for digging and burrowing and exploring more than base. And so these are at levels higher than baseline. So she wants them, group 1 should groom at rates higher than baseline, and group 2 should do digging and burrowing more than they did at baseline. And here are the data. And what you'll see, this is really interesting. So you can see that there's some behaviors respond very well to reinforcement and others behaviors do not. So look over here, and what you'll see is that this kind of scrabbling around and digging and rearing up, all of these behaviors are very, very high level. So here's their baseline, and here they are when they're receiving reinforcement. So you see this huge, massive increase in terms of the number of seconds that they spend engaging in those behaviors. But the behaviors that are related to scratching and face washing don't change. They stay down here. And when she puts them back into extinction, these continue to stay low, and these behaviors that were reinforced begin to drop. And so what we see is this evidence that these results are very consistent with the behavior system's explanation. Food is foraging related, and the behaviors that increase are foraging related, but the same amount of food reinforcement has no effect on face washing or scratching, and it doesn't affect, here's scent marking. It doesn't change either. But that's because scent marking has to do with territoriality, has nothing to do with food. So these data are very consistent with the behavior system's explanation. Okay, so in the second study, Svenster in 1973 studied the relationship between specific target behaviors and different types of reinforcers. And he asked whether or not certain behaviors would respond more favorably to different reinforcers. And he studied 3-spine stickleback fish. So here's our little 3-spine guy. All right. So Svenster used 2 different kinds of reinforcers. Now, instead of using food, he's using 2 reinforcers, and neither of them are food. One of them is access to another male, and the other is access to a female. So whatever the behavior is, the fish earns access to another male or to a female. And this is all done during the breeding season. So, and the 2, pardon me, the 2 behaviors that he requires are swimming through a hoop or biting a metal rod. Now what that means is the first behavior, swimming through a hoop, it's sort of like the little hoop on the end of the stick that you use to blow bubbles. It's a small hoop, and it's suspended into the fish's tank. And the goal is to get the fish to swim through the hoop. And if he does, or as he gets closer to the hoop, he receives reinforcers. Some of the fish receive access to males. Other fish receive access to females. And they want to see which one is more likely to learn to swim through the hoop. The other behavior that he uses is a small metal rod is suspended into the tank, and the goal is to get the fish to bite the rod. And so they're using shaping techniques, and they're moving the fish closer and closer, but they're using either access to a male or access to a female. And the results that you get depend on both which behavior and which reinforcer you're using. And so they basically are, the results depend on the behavior system that's activated by the reinforcer. So any fish who's gaining access to another male are going to learn, will have the territoriality system will be activated, and behaviors related to territoriality are more likely to be reinforced. And the fish that are gaining access to females, that's going to be the mating system, and so behaviors that are more associated with the mating system are more likely to increase according to the behavior system's approach. And so here's what he finds. It's kind of interesting. So he's got 4 groups of fish. Half of them are learning to swim through a hoop, the other half are learning to bite the rod, and half of each of those will get either a male fish or a female fish as a reinforcer for whatever the behavior that they're doing is. And what he found was that when he uses access to a female, it was very easy to train a fish to swim through the hoop, but not very easy to train the resident male fish to bite the rod. Now, you may ask why, but remember that if you think back, remember that the 3-spined stickleback builds a nest that's kind of a tube, and he swims through the tube. He'll court the female, and then he swims through the tube to show her where his nest is, and tries to get her to swim into the nest to lay her eggs. And so that behavior, swimming through the hoop and swimming through his nest, are similar, easy to train when the reinforcer has access to a female. They don't bite things when they're in their mating mode, so biting the rod isn't very successful when they use a female fish. However, the opposite is true when they use a male fish. Remember, during the breeding season, the males are very aggressive and very territorial. They will attack other males that come in, and they will rush at them and bite them. And so it's very easy when you're using a male fish as a reinforcer to train your resident fish to bite the rod, but it's not very effective to train swimming through a hoop when you're presenting a male fish. So in this case, you are using the female fish is activating the mating system, which makes hoop swimming easy. And in this case, when you're using a male fish, you initiate the territoriality and aggression system, and so biting the rod becomes very easy, but not swimming through a hoop. So these data were very consistent with a behavior systems approach. The last study that I want to talk about is a study by my advisor. That's my Edmund Fentino from the University of California, San Diego, trained in at Harvard in B.F. Skinner and Richard Herrnstein's lab in the 1960s. And in this study, with a couple of his graduate students, he studied the effect of food deprivation on free operant choice behaviors. So he gives his Siamese fighting fish a choice between going to one side of the tank to feed or going to the other side of the tank to display in a mirror. If you know anything about Siamese fighting fish, they're very, like 3-spined stickleback fish, they're very, males can be very aggressive toward other males. And if you put a mirror into their aquarium, they will puff up and their fins get really big, and they try to scare away the other male. And so the Siamese fighting fish were given a choice between going to one side of the aquarium, say, I'm gonna use my cursor here, going over here to this side of the aquarium to get food, or going over to this side of the aquarium to look in a mirror and display. And this little guy is displaying in the mirror. And so, and what he did was the independent variable here is food deprivation. So we're choosing between the feeding system and the territorial defense system. And what they did, what their manipulation was to measure choice over a number of days as the fish became more and more food deprived. Remember, fish are cold-blooded, so it takes a while for them to get hungry. And what they find is that their choice to either feed or over here to defend their territory depends on how long they've gone without food. So Here you can see that the hours of deprivation go from 0 all the way up to 240 hours. 240 hours. So this is out to 10 days of food deprivation, and which is not uncommon for fish. They can go many, many days without food. And what you find is that in the first 48 hours, all 4 of these fish show a preference for the mirror image over food in every case, and a dramatic preference for displaying in the mirror rather than eating. And as the number of hours increases, we get out to 120 hours, and now you can see that we're 6 days out, and the rate at which they are looking in the mirror has come down. The two are more similar to each other, and it really is. They have to get out to this 240 hours later in order for the behavior to reverse, to show that they have a preference for food over displaying in the mirror. And 3 out of the 4 fish show that pattern. And presumably, if we carried this out to say another 24 hours or 48 hours, fish number 4 would probably show the same pattern. So the results show that food deprivation changed the probability of one behavior system being activated over the other. So you have 2 systems available, but which one is stronger? And it's directly linked to food deprivation. The longer they go without food, the easier it is to activate the feeding system and to override the territorial display system. So again, consistent with the behavior systems approach. There are many, many studies that have similar findings, but these are 3 great little experiments, I think. Findings from all 3 of these studies, as well as many others, appear to be very consistent with this idea of behavior systems. It suggests that while the fundamental idea of reinforcement is true, remember, if we go back to the very beginning, they thought all reinforcers were created equal for all behaviors. But it turns out that that's not true. It is true that behavior followed by reinforcement strengthens behavior. However, certain types of reinforcers belong, if you will, with certain behaviors and make it much easier to increase those behaviors. So in the 1960s and the 1970s, we kind of gave up on this equipotentiality hypothesis, and we sort of in the operant conditioning world, we sort of adopted the ideas that underlie belongingness in the classical conditioning world, and found that there were biological constraints on learning as it relates to specific behaviors and specific reinforcers. Okay, so this is the end of the second lecture in the series of for chapter 5B, and we'll see you back for the next lecture. Have a good day.